So this is part two of the quick introduction to Linux for programmers. I noticed that I forgot to talk about this command last time. It's not too bad that I didn't do that though, because it's kind of complicated. So if I do ls-l, you can see that these permission things, and I didn't explain what these are last time, and the header isn't very useful, is it? It doesn't tell you much information. Um, so there are three possible permissions that you could have here, and then there are also some other weird things like divs for directory, and there's more exotic things like sticky bits and set UID bits that I'm not going to talk about. But what this basically means is that these are the permissions that the user um, has for the desktop junk directory. So it can read, write, or execute it. Why you would want to execute a directory is beyond me, but I have permission to do that if I want to. This second column is for group owner permission. So the group owner here is also me. There are groups in Linux that your user can belong to. For example, if you have sudo working on your machine, then you are a member of the sudo users group, and that's sort of an advanced topic. You'll probably never need to know anything about that just for writing programs on Linux. This last column is for others. So those are just people that are not the user owner and not the group owner. So it's sort of like everybody else. So for this, everybody can execute this directory. Isn't that great? And chmod is for changing those permissions. So maybe I want to. It's actually just sort of more sane if let's take away the user's option to execute that file, desktop junk. Okay, and if you look again, now you'll see, where did desktop junk go? Now it's no longer executable. And what if I want to remove everybody's right to execute it? Then I can do chmod all -x, and now nobody can execute the thing, which makes sense, right? Nobody wants to execute a directory. And if you want to do things just for, maybe you want to give the group write permission, so you could do that. And now the group has the ability to write to this directory. And so there are other ways to do this using octal numbers, if you know what those are. So 777, this is just all one, so this gives everybody permission to do everything. And let's look. So now, yeah, now it even looks weird because everybody has the permission to do everything. Another common one is 666, because that just takes one away from each and removes the execute permissions. And so now if I look at it again, everybody has read and write permissions, which is sensible. So I'll just leave it there, and that's how chmod works. If you want to be a real master, then you should check out set UID and sticky bit. And here are sort of these workhorse commands. These are commands that you might use every day, especially if you're doing programming type stuff. So I can't explain all of these things in isolation, or I'm not going to try to anyway, because the real beauty is that they interact to accomplish complicated stuff. And so let me just give an example of what I mean. So let me find some file, like this file, publications.html. Maybe I want to look and see what's in that file. So one way just to look at the very first few lines of it is the head command. So this is really useful. So that's the head of that HTML command, that HTML file. If I want to see the whole file, then I can use this really important command called cat. It doesn't seem like that would be super important, but it's a very important command. And what it does is it just dumps the contents of a file to the screen. Now that went by too fast for me to see, so I can pipe that to a program called less. So this vertical bar is called a pipe, and what it does is it takes the output here and makes it the input here. And so the output of the cat command goes into the input of the less command. And what the less command does is it just opens it as sort of a document. So you can scroll up and down. You can also do searches in here, and I did that just by using backslash, and so you can do word searches and other interesting things. And let's say that you want to know more about that you find this program interesting, and you want to know more about how it works. It would be nice if you could read the manual. And there's a command called man, which is for manual, which lets you read the manual of any command you want, anytime you want, assuming you have the documentation installed. So if you read this, you can find out everything that you ever wanted to know about less. Sometimes it's kind of hard to read this. Now that there are internet tutorials, sometimes you can just Google Linux less tutorial and find out more and more quickly, but this is really an exhaustive explanation of everything it does. So notice that like every other program, there are many command line options for the less command. And what else have we got here? So top, very useful program for programmers. It's kind of like the task manager in Windows, in that it shows you what processes are running and what kind of resources they're using. So those are the programs that are running on my machine. Every process has a process ID, which is important in Linux because this is what you use to control these things. And then there are other things, CPU percentage being used is interesting, and so is the percent of the memory being used, and how much real time how much real processor time they've used. Xorg is what displays the desktop, and this is what I'm using to shoot my video. It's kind of a resource hog, and this is compressing a previous video that I made. And here's Firefox and some other things. So I'll talk about that when I get to PS. Where's PS? Alright, so I guess I'm not going to talk about these things in order. If you want to know more about the processes that are running on your machine, PS is the command that does that. If you just type PS, nothing very impressive happens. If you want to see everything, then you can do PS AUX. And notice that went by too fast for me to see, and so I pipe it to less so I can actually look at the stupid thing. And these columns are who's running the program, what the process ID is, and init is this, unless you have a distribution that uses some other thing called systemd. This is the first process created. It creates all the other processes, and so in Linux, processes have a kind of a tree structure, actually I'm sure in most other operating systems too, which you can actually see with the pstree command. So init spawned all these programs, and some of these are in turn spawning other programs. And here's Genie, here's record my desktop. So those are children of the GNOME session. GNOME is like the desktop manager. Let's go back to just the PS though. So what else have we got here? So what is this column? I don't know what that means actually, but this column is interesting. This tells you which terminal window. There are many terminal windows open on my machine, and this tells you which terminal window these programs have been assigned to. And every time there's a question mark, it means that there's no real way to get a handle on those programs. They aren't really running anywhere, and we call those daemons. In fact, you can see this right here is called daemon, and it just does stuff that needs to be done. So most of the programs running on your machine are daemon programs. Here's one that apparently I'm running a program called Getty, and in one of my open windows. Another nice set of options for PS is FU. U stands for user, F stands for full, and you have to type in the user that you're interested in, which is narcissistic vanity PS command here. I'm going to see what I'm doing, and I'm running these. That tree structure that I showed you earlier, you kind of implies that there must be some way of keeping track of what the parent of a process is, and that's what this is parent process ID. So here's the process ID, here's the ID of the process that spawned that process, And these are all the programs that I'm running. So it's even with the less command, it's still kind of a mess, isn't it? You might want to know just some things about like what's going on with programs that have to do with Firefox that I'm running. So what I used is I piped to this search command called grep. And if I were a better nerd, I would know where that name came from, but I have no idea. But it basically means search, and it can search in all these kind of powerful ways. Uh, this is another thick book if you really want to master grep. But just using it like this is how you use it 99% of the time. And what it's doing is it's just selecting the rows of output that say something about fire. So the grep command itself shows up, and some plugins for Firefox show up, and Firefox itself shows up because I'm running Firefox. So what if my Firefox is hung or something and I want to kill it? So this is a useful program, kill-9. And you think, why do you have to do -9? Well, kill is actually a pretty complicated command that you can use to do inter-process communication and send signals. That's kind of something that you don't have to do very often unless you're a programmer, but I'm assuming that the audience consists of programmers, so you might find that interesting. Maybe you could read man kill and find out all about that. But I'm going to kill Firefox, and its ID here is 6496. So if I do 6496, it's dead, and now you'll see that it's not there anymore. So now the grep command is the only thing running that has anything to do with Firefox. If I want to start it again, I can start it from the command line, and there it is. But notice that this kind of kills my terminal window. It's hung now. So let me hit Control C. If I want to run a process in the background to get my prompt back, you can do this ampersand at the end of your command, and what it does is it returns control to you. Sometimes though, the programs that you started in the background, they'll send out error messages or something, and those will kind of come back and like this, right? So it still gave me this little bit of output there because it came from the standard error stream, I think is why it does that. But if that doesn't bother you, then like it doesn't bother most people, then this is a useful technique. What else have we got? Diff. So diff is a very useful command for programmers. And let me go look at some program. So where am I keeping some programs lately? Let's go to the documents folder. And maybe I just want to see all of the C files. Oh, there are no C files there. So that goes to my home directory. I'll go to my Dropbox. I'll go to my 360 folder, and I'll go to hello class where I've been writing a bunch of C code. And now let's look at just the files that are C code, and so those are star of the form star-c. So this star here is important. It's called a wildcard, and it stands for anything. So grep is going to search for files that are of the form blah.c. And these are the files in the folder that are like that. I thought there were a lot more. You can see that there are many more, right? And okay, so ls has the ability to do it just like that. I'm not sure what happened there, but I'm not going to reshoot the video just because I look slightly like an idiot. So there are a bunch of C things here. One of them is this encryption program that I sent out everybody in my class. So I've already used one command line editor called vim. I'm going to use another simpler one called nano to look at this. And so let me say that I change a couple things in this file, like this. And so I'm not very familiar with nano, to be honest with you. So I'm going to hit Control X to get out of here. And it says save modified buffer. And so I do want to save the changes, so I'll hit yes. But I want to change the name of this file, so I'll call it tbe2.c. And yes, okay. So now I have two slightly different files that have really similar content. So when you're programming, sometimes you want to see exactly what the differences are between two, let's say, code files or two output files, and a really useful command for that is diff. And so this will tell you if there are any changes between two files. It's very useful. So this says that the difference is on line 9, and the left arrow tells you that this is the version that's in this, and the right arrow tells you that this is the version that's in there. So you can easily see what all the differences are. Maybe you're writing code with somebody else and they make changes and you want to know what those changes are. You can use diff to find out. But some people don't like that kind of ugly command line interface, and so somebody wrote a program that does that same thing, but with a nice graphical interface, and that program is called Meld, which is very nice. And here is just sort of a graphical version of what I was just saying. It's indicating that there's a change there, and it maps changes from file to file, which is very useful for coding. What else have we got? So knocked off Meld there. Maybe we should go ahead and do these at the same time. So these are hex viewers. If you start doing especially digital forensics type things, frequently you want to see, all files are zeros and ones. Zeros and ones are a little bit hard for human beings to understand, so hexadecimal is sometimes said to be the interface between the computer and the human mind. And what we have here are hexadecimal descriptions of what's in this file actually as zeros and ones. So if you know hex, then you can read this. If you don't know hex, then I can't explain it to you in 5 minutes. This is hexadecimal 10, so this is actually 16. And this is 1 byte, 2 byte, 3 byte, 4 byte. If you counted, you'd see that there are 16 bytes here, and so it starts. That's why this is hexadecimal 10. 16 starts in the next line. It gives you some ASCII version of what's in the file because it recognizes these as ASCII characters. By the way, another great command, if you forget about what the ASCII characters are, in hexadecimal, you can do man ASCII, and it gives you this nice table, which is very useful. So, capital A is 41 in hex. That's the kind of translation that's happening in the XXD program that I just used. Another hex viewer that has a little bit nicer output is called bless, and we can use bless to look at any file, including that one. So here's what bless looks like, and it gives you a little bit more information. It's more complicated. So that's what it does. And where are we here? We've got that, got that. Head, fine. Oh, DU. DU stands for disk usage. So if I do DU, it tells me the disk usage of, I guess this would be all the directories in the file. But you can also do DU for individual files. And so what this is saying is that this takes 4 kilobytes. That's not very, just 4, sometimes you forget what that means, whether that means bytes or kilobytes or whatever. So you can turn on this -H flag, which I think stands for human readable. So let me go back to my desktop. I want to show you this nice thing that you can do with DU. So if I type DU here, it tells me, notice that here there are some, it's because I changed the permissions. Let me undo that. chmod 777 desktop junk. And now I'll do DU again. Now I do have the permissions to check these things out. And I'll do -H so that I can actually understand what the hell it's saying about each of these files. And it's doing nothing but the directories, right? And it's telling you how many kilobytes or sometimes megabytes those directories are. What if you want to find the one that uses the biggest amount of memory? You might have to look through. That's kind of tedious. So you can pipe that output into the sort command. And the problem with this, though, is that it sorts it in alphabetical order instead of numerical order. So sometimes you'll get higher numbers, like right here. 36 megs comes before 4 kilobytes, and that's not really what you mean, right? So if you want to actually get a good comparison, then you need to do -n to tell it that you want it to sort numerically instead of on the basis of alphabetical order. And you can see that desktop junk, this, remember dot is the file, is the directory that we're currently in. So the current directory has this much memory usage, and I think these are in kilobytes, and the biggest hog here is this subfolder of desktop junk, which is just the desktop junk folder itself. And it's because I have some big data files that come from the Microsoft Connect, basically movies. All right, and so where are we? So we've got du. WC is a very nice command, and it's WC stands for word count. So where am I now? I'm back. If I want to see where I am, remember I type pwd. So let's go back to Dropbox 360 hello class. Maybe I want to know, maybe I'm writing a novel or something, and I want to know how many words and characters a certain file uses. So let's do stego.c. And what this means is that this file has 214 lines, 1,045 words, and 6,777 characters. Here's another example. Maybe I say Beetlejuice, 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 and echo just repeats whatever you typed into it, just like the name suggests. But I'm going to pipe that into WC, and you can see that there is 1 line, 3 words, and 21 characters, including spaces. So that can be a very useful command. SSH. So SSH is another thing that you could probably write a book about. Here I'm running in a virtual machine a copy of a Ubuntu server, and I don't know if you can see this. I'm sorry I didn't make the font bigger. Can I change that? I don't know. I'm not going to bore you trying to do it now. But on my local network, this server has a certain IP address, which is 192.168.1.14. And I'm going to log into this machine from my terminal window. So this, all the stuff that I'm doing in the terminal, I can also do in a remote computer, which is one of the great things. So I've already typed this command once. Let me see if I can find it in my history. And yes, there it is. So history, by the way, it dumps all of your previous terminal commands to the screen, and then I use grep to find the one that talked about SSH, and now this is the command that I want to enter. And -p is for port, so I want to SSH on port 22 to this user, Hunter, at this IP address. And so let me do that. And I'm logged in now. This is Hunter at Bob, not Hunter at my other host. So I can actually do stuff on this machine. So if I wanted to work on my home machine from work or vice versa, I could do that. And this machine, of course, has totally different files on it, and it's a different environment. Okay. So SSH is very useful, and it's much more could be said about that. This file, this program, which is good for determining whether or not something is installed on your machine. Oh, did I just exit my terminal? No, it's still there. So sometimes some programs are installed on your machine, and sometimes they're not. So maybe if I want to know is XXD installed on my machine, it says yes. Actually, this gives the full path to the program. So if you're a long-time Windows user, you know that there is such a thing as a path. When you type a command like cat or something, what happens is that the machine looks for that command somewhere along the path. And let me just show you what my path is. You can access that as an environment variable called path. So whenever I type the name of a command, my system looks for the executable to be in one of these directories, like user local games. They're separated by semicolons. Most of them are in user bin. And sometimes I write my own programs and put them in Dropbox bins so that I can use them in all the virtual computers that I have. If you want to modify your own path like this to make custom directories come up every time you log in, then the way you can do that is to go to your home directory and edit your .profile. And so here you can kind of imitate what I've done here. This is the the path is automatically generated, but if you want to put your own little embellishments on it, then you can do it something like kind of like that. Um, and what else? So ping is a command that is good for seeing if your internet connection works. Maybe your web browser is being slow and you're not sure why. So you can ping Google or something and see how well things are working. So it's mostly what I use that for. And touch we've already talked about. It just creates a file if it doesn't exist. If it already does exist, it modifies the timestamp so that the last modified date gets updated to like the present moment. This kill all command is kind of useful if you're too lazy to use PS before you do your kill. So let's say that I want to kill that stupid Firefox again, then I could do kill all. So it's kind of a pleasantly violent command. But I guess Firefox is not running. Um, and I don't want to kill any other programs. But if Firefox was running, that would have killed it. Um, what else? We've done PS, we've done PS tree, we've done tree, we've done history, we've done grep, sed. No, we haven't done sed. So sed is a little bit obscure, but it's really cool, and it has to do with regular expressions. And if you don't know what regular expressions are, that's sort of a topic all unto itself, which you could write a big book about, and many people have written big books about. So let me pipe this out to sed. Sed stands for stream editor, and what you usually want to do with sed is just do a search and replace. So let's say that I want to replace R with capital R like a pirate. And you see what happened here? Expressions are regular, but this did a search for R and replaced it with R. And that's surprisingly useful, and of course sed does a million other things. Like I said, sed is its own programming language, so it's a huge topic, and you can Google that if you want to find out more about sed. MD5 sum. So this is the MD5 hash algorithm, which is no longer considered a secure hash algorithm, but it's still used a lot. And one way it's used is, let's say you download your Linux distribution, probably that it told you to do the MD5 sum of what you downloaded, and it told you what the MD5 checksum was supposed to be for your Linux distribution. You probably didn't do it, and I rarely do it too. But the point, is it detects differences. So notice if I change just one thing here, like I'll put in 2 spaces instead of 1 space. Now the checksum is completely different. So what it does is it detects people secretly messing with your stuff. So let's say the NSA is standing in between you and the Linux mirror where you downloaded your distribution, and they changed a few bytes so that they can spy on your machine. And maybe you never would have realized it, but if you compute the MD5 checksum of your ISO, then you can detect people messing around with your stuff. Or it could, there are lots of other cryptographic hash functions that are also used for this purpose, but MD5 sum is mostly used for making sure nobody has messed with anything. Sort we've already talked about. If config is kind of cool. It tells you a bunch of things about your network. In particular, it tells you your internet address, and so this is some MAC address stuff. So if you know how MAC addresses work, you could figure out the brand name of my router. And yeah, so what else have we got here? Time is very useful for programmers because you can time how long it takes to do something. So let me go back to you can time any process, but I have one in mind that actually uses a non-zero amount of running time that would be an interesting thing to time. And ls_star.py, let's look at the Python scripts in here. And I want to time how long it takes me to do steger.py, and then would it actually do this history trick again? Oh, I haven't ever run it on this terminal. So what I have to do here is, you know what, I give up. I'll time something less interesting. Let's see how long it takes to run ifconfig. Okay, so this tells you how much time actually elapsed, and these other two have to do with how much time was used on the processor, and I forget which one is which, so I'm not gonna fudge it. But if you're studying algorithms and asymptotics, or you just want to write efficient programs, then this time thing alone is reason enough to work in Linux instead of Windows. Clear clears your terminal screen. Control L does the same thing. Cat we've talked about, man we've talked about, and this video is getting kind of long, so I'm going to stop it here.